So first of all, we have to import a library because I think at this level, the best would be that we just create a data set synthetically. So because the actual data set will have multiple dimensions, and right now we just want to focus on how um, linear regression works. And then after that, we will step by step build up in doing data pre-processing and then handling more complicated data set and other algorithms. So the first library that I'm going to import is going to be NumPy. NumPy is very good at computing, numerical computing, and also for this specific one, we are using it to create a synthetic data set that is just numbers. And because we want to create our synthetic data set and it's going to be all numbers. So import numpy as np. I just say as np because it's going to be easier to just refer to it as np inside of our code instead of just writing the whole numpy. Okay, so we first imported that, and then the next library that I'm going to import is matplotlib, and we are using that for visualization. Matplotlib.pyplot, and then for this one we are going to import it as plt. Okay, so of course we have to import the linear regression, and that is going to be from sklearn linear models. Linear regression is a supervised learning model. So for that, we have to split our data into the train and test because we keep a portion of our data and we don't show it to the model. We keep a portion of our data and we don't show it to the model. So model have no idea what this data is. And based on what it is trained on, it will try to guess, and then we see how well the model is doing. For this, I have to import model selection, import train test display. Now we're going to generate our data set. This is going to be a 2D numerical data set. And as we said, it's going to be generated from NumPy. Create a random number. And then this is going to be a 100 by 1 array. And then for that, I have a corresponding y for times x plus another random number. So this one again is one column and 100 rows. So I have 100 data in this column. And okay, so there is something else that we have to do here. And I will show you what happens if you don't do it. I will write numpy.random.seed. And I'm going to set this to anything like 42. You can set it to anything, but what it does is that make sure that each time this random number is going to be the same as the previous one because you want your code to be reproducible. Because you want your code to be reproducible. If you don't do that each time you're running this code, you're going to come up with a different random number. So if I want to show you this code, it's not going to be exactly the same as the one that I created myself. So this will help reproducibility of your code. Now that I have my data set, I have to split it into train and test. I will use the train part to teach the model how it should predict. And then when the model learned the pattern, um, then we're going to use the test and to see how our model did. So this is going to be test and train split x train. Okay. So right now you see there's a relationship between x and y, and we want our model to figure out this relationship. If it would be able to figure out this relationship, then that means that our regression model did well. So now that I'm splitting, I do x train, x test, y train, y test. And then for our test size, I'm going to make it 0.2. It is generally 0.2. And that means that 20% for test. And then again, because when we are splitting, this is going to be a random split. So again, I have to create a random seed here because I want my code to be reproducible. Just with random seed, that means that you're going to get the same response every time. We're going to name our model, and we are using linear regression. So I'm just going to declare that here. Now I'm going to train our model dot fit, and then x train and y train. Now we're going to predict the data set. Y predict is going to be model dot predict, and we're going to use our x test. So okay, first I'm just going to visualize it. So I'm going to say plot it. Sorry, I should have done that earlier. So this is how we're going to plot our data. It's going to be in scatter plot, and also don't confuse this label here with the label of supervised learning. This is not the label of a supervised learning. This is just the label for the plot, or maybe the title, I should say. We did all of that, and I'm going to show you something very interesting, and that's why we don't need accuracy or anything like that. So the first one that I'm going to print is the intercept. Okay, so let's run this and then look at it. So we ran this once. These are all of our data points everywhere. And then we have our linear regression line, which is that the color is going to be red. So this is our linear regression. As you can see, the data points are all over the place, but we found, or I should say, our algorithm created a line in a way that is going to have the least amount of error. Okay, so then when we created that, look what happened. I have the intercept here. I'm saying the intercept is starting at 4. My slope is 2.59 or 2.6. And then look at here. So for y, we set the y to 4, and then we set the slope to 3. Look how close it is. Now, if for example I change this, let's change this to 6, not 60. Let's change this to 6, and then I'm going to change this to 8. Let's run again and see if we get the correct answer again. Here again, I have 6 and I have 7.59.